Hi! In the last video about the power supply project, a few of my viewers raised an interesting point around safety. Now, while I am very experienced in wiring electronics and dealing with mains, in fact in my past career I used to work with everything up to over 70,000 volts in high voltage resistor test equipment. So I am familiar with all the safety precautions and things like that. But nevertheless, it is, I think, worthwhile spending a little time around how to create something that will help to protect you when you're working on your bench, especially if you're working around mains and you're doing your own power supply and things like that, where you do run the risk of being exposed to 110 volts, 240 volts, depending on where you live. So what I want to do is spend a little time on this video to actually show you how to build a little safety outlet socket that you can plug into your own power supply that goes between your normal household mains and your equipment under test. Now, one of the things I want to point out, and we had this discussion on the Element 14 community a little while ago, is that fuses are not there to protect people. Fuses are there to protect the equipment and the infrastructure, like the household wiring and things. So there's no way that you could put a fuse into a circuit of sufficiently small enough capacity that it would prevent you from getting seriously electrocuted if you touched the wrong side of it. The circuit that I'm going to show you, I am going to put a fuse in it, but it's not because of protecting me, it's because of protecting equipment. The second thing I'm going to do is to put a ground fault circuit interrupter into a box as well. And what this is for is if for some reason I do touch, or anybody, if you build your own, you touch one of the live wires and provide a circuit through yourself to ground, it will trip both the live and the neutral from the socket and therefore prevent you from being electrocuted. Now, if you're using an isolation transformer, then an earth leakage circuit breaker will serve no purpose whatsoever unless you have a ground on the other side of the isolation transformer, which of course completely negates the point of having the isolating transformer in most cases in the first place. So if you're going to use a transformer, then you don't need this earth circuit breaker in your outlet. It doesn't harm to have it there on the right side of it, but the reason I'm saying this is because I didn't want anybody to think that because you've got an isolating transformer which takes say 240 volt off the mains and it still gives you 240 volts on the output, that putting an earth leakage circuit breaker in there will help prevent you from getting electrocuted. It won't, unless you have one end of your isolated transformer grounded, which means now it's no longer isolated, because isolated means isolated from ground, then it's not going to provide any protection and it just won't work. Now, I'm not going to demonstrate that to you, but I will put some circuit diagrams up when I'm editing the video in order to show you what I mean. Anyway, so what are we going to build here? I went along to the local hardware store to get some electrical boxes, and the first thing I looked for was something that would be big enough to carry a ground fault circuit protector, and this is one of the ones that they sell here in Canada, and it's going to be the same for the USA. Obviously in the UK and in Europe, the outlets on it are going to be different, but the basic principle of operation is exactly the same. The live and the neutral wire goes through a sensing element. As long as the same amount of current goes up from live and back through neutral, then the sensing element is balanced out. The minute that a path back to the switchboard or back to the the neutral part of the transformer back out in the street is provided through you or some other piece of equipment, then there's an imbalance in the circuit fault protector and it will trip within just a few milliseconds, and it only takes about 30 milliamps of current, which is not enough to kill you, to actually make these things trip. Now, you can get child friendly ones, which are much lower, down in the region of about 5 milliamps that they'll trip. The one I'm using today is a standard 50 milliamp one. Sorry, 30 milliamp one. So anyway, you got to put this into something. Now normally this would be wired into a socket on the wall. What I want to do is put it into an external box so that I can use it in different locations and just move it around. I also want to have a switch on it so that I can literally turn the output off without having to pull the plug out as well. So to that end, what I've also got is a standard 2-pole switch. Now I wanted 2-pole because I want to disconnect the live and the neutral when I turn the switch off, not just the live, which is the same as what the circuit breaker would do if it tripped as well. It would disconnect both of them. That way, even if I've got the wiring wrong somewhere, when I turn it off, I know that I'm protected both, from the live and the neutral side of what's coming out of the socket. So this will allow me just to switch on and off the output quite easily without having to trip the circuit fault breaker. All right. So that's the second piece I've got, but neither of these two have a fuse in them. So the third thing I've got here is a mains rated, it's 250 volt AC rated at 15 amp screw-in fuse holder. So you can put different fuses in here up to the rating of this, which is 15 amp. So what I have as well is a selection of fuses. So you just drop them in there, screw it down, and you're done. And this is going to protrude out the side of the case that we're going to put this in. So what I did was bought a couple of packs of fuses. So I've got a 10 amp and I've got a 5 amp, 5 of each, all right, because inevitably we're going to blow some. And then the last thing I've got, well, not quite the last thing, the case to put it in, looking through Home Depot, which is our local hardware store, they have these very solid, they're designed for going surface mount on walls. In my case, I'm just going to have it sitting on the bench, or I'm going to screw it to the back of the wood of the bench. It's got knockouts that you can poke holes through so that your wires can come in and out. They've got them on both sides. By default, they're blocked, which is good. I've knocked the smaller one out of here for the moment because that's where I'm going to put my mains cable so I can plug it into any of the sockets. And inside there's a ground strip that runs across all of the things that you screw onto here so that it will connect the grounds of all of the switch and the circuit fault protector. And then there's a ground wire here that you use to screw into your socket and to make connection to the ground that's coming in from the outside. Now the other thing I might do with this is I picked up a screw together adapter so that I can actually put an outlet socket on the end of a flexible cable too, so that I could have it close to me when I'm working on some circuits and just plug it in and out of here, but still have the protection of the ground fault circuit interrupter. And the circuit interrupter actually has an additional set of terminals on it for that exact purpose. So these first two that are on here, they're not covered by default. That's where you bring your mains in, and then you've got protection on these two sockets. But if you actually take this tape off and run these two out to an additional outlet, then it will provide ground fault protection for that as well. And in homes in Canada, it's quite often to see, quite common to see one circuit protector like this put in one bathroom, but the actual wiring from the outside of this going to the other bathroom, and maybe an outside socket or something like that. So it'll actually provide protection to many sockets in one circuit. Now, the last thing that you need is proper strain relief for a cable. So if I find, where's the cable I've got? So what I've done is I've got a standard mains extension cable. I've cut the plug off the end. It was your standard cloverleaf kind of plug on the end here. I've cut that off and stripped back the wire carefully. You've got to make a point of not nicking the wires where you're cutting it away from the insulation, because that will still be dangerous. And the other end has got the fully molded normal plug, which is great. But one of the things I did was I picked up a couple of adapters at the hardware store for strain relief, because you have to have proper strain relief for this cable coming out. And the first one I picked up, which looked initially like it was going to work, was this one. And the problem with this is no matter how tight I screw that in, which basically brings these tines inside, it will not grip this cable, not even remotely. So the problem with that is that's not going to provide you any protection at all. So what I did was I found this one. Now right now it's got a much bigger hole in it. It's a much bigger strain relief unit, and it comes with a main piece that you screw into the side of the box, but it also comes with a large selection of rubber grommets and of different sizes and shapes. And basically this one here is the smallest one, and that's perfect for getting a tight fit around the cable even before I screw it in. So that's going to give me a nice good firm grip of the flex cable for doing the wiring to the socket. And if I put the extension cable out the other side, I have a second one of these, so I can actually have full strain relief on that side too. So anyway, let me just readjust the camera and we'll start putting this thing together. Okay, so this is the closer up view of the plate that I'm going to put it into, sorry, the box I'm going to put it into. And what I have here is a plate that's going to go over the front once I've got the parts put in here. And the ground fault protector you can put on one side, right, and it just screws into these terminals. I'm just going to lay it beside it at the moment. And then the switch I've got here will go on the other one like that. And what will happen then is that this plate will fit over the lot and give it a nice finish. Okay, so that's the intention of what we want to do. And then I've got the fuse, of course, which I want to put in here. Now the ground fault protector is quite thick, so I don't have any room underneath that to put the fuse in. But if I actually put it on this side over here, it looks like it will go underneath the switch once it's screwed down. There's quite a bit of room down there. So what I'm going to do is I'm going to drill a hole on this side of the case. So if I just put this on the top here a second. All right, I'm going to drill a hole on this side of the case here, roughly about here, so that I can put the fuse in there and it'll be easily accessible to me to be able to change the fuse if I ever blow it. All right, so I'm just going to stop the camera and go out and drill a hole, and I'll be right back. Okay, so nice neat little hole just at the bottom of the box, slightly off the bottom, so that we can put our fuse holder in here. That'll go in there nicely. All right, it leaves us a little bit of room to wire it, put some heat shrink over to insulate it. Not that we're going to need that necessarily. Strictly speaking, everything in here is going to be live anyway, and it's going to be well insulated. So, but we'll put some on anyway just to be safe. So next step is to get the extra bits of wiring in and start soldering things up. So be right back. Okay, so we've got the fitting for the grommet screwed in, and you want to make sure it's screwed in nice and tight, and it comes with a little O-ring which helps give it an even tighter seal. I guess if you're using it in outdoors or something like that, you need to be waterproof, then that's what it'll do for you. The next thing is to make sure you get the right grommet size. So if you remember with this, we had the really small one, which is not that one, it's this one here. So we pull that off, and that's the one we want. Now, got to remember, for your cable, don't put it through and wire it unless you got these pieces in. Right, put them in the right way. So feed that through the cable. Yes, it looks really big, but it's going to provide a very secure fitting. And you want to have this so that the main slope is towards the screw back, because it's going to be compressing on that. Push your wires through and push a reasonable amount of the cable into the box, because there's nothing worse than having a few inches short inside when you're trying to wire things up. And if you've got a little bit extra, it's not going to do you any harm, and it allows you a bit of extra comfort when you're wiring, that if you need to strip it back a bit further, you can. So then now you can start. So this will still slide right now, but once I screw this down tight, it's going to compress quite significantly onto that grommet, and now I don't have it quite tight enough yet. Right now I shouldn't be able to pull that out. So now got our cable coming down, coming into the strain relief here. All right, that's nice and tight. If you need to use a wrench to get it a little bit tighter, then do so. is our wire coming in. We've got plenty of wire now for wiring, and I can actually pull that quite significantly hard and it will not budge now. So, but it's got a nice rubber seal here and a rubber protection, so it's got some good strain relief. All right, and that's important because if it's got a sharp edge or something like that, the last thing you want is for it to start chafing and splitting on you. All right, so the next thing we're going to do is take the live, which in Canada the black wire is the live and the white wire is neutral and the green wire is the ground, and that's going to go to the end of the fuse here. Now you want it on the very tip of this fuse. Let me just zoom in a little bit here. All right, on these fuse holders you want it to be on the tip, and the reason for that is because if the fuse blows and you're taking this out to replace the fuse, you don't want the end nearest to you being, all right, on here, being the live end. All right, what you want is the one that's furthest away from you, which is the one way down the other end of here, not this one. So you take your live to here, and then this is the one that's going to go up to your box. All right, let's just zoom that back out a little bit again. So in this case, I'm going to leave a little bit of extra, but I'm going to bring it around and I'm going to solder it onto here. So here's the first stage all wired up. I've got the live coming in to my bottom end of the fuse, out of the fuse into one end of the switch. The neutral comes in onto the other side of the switch, and then I have the two wires from the load side of the switch, which are going to come across into the ground fault protector in a moment. So that's all wired. I put some heatsink over the top of the connections onto the fuse as well. Not that it's going to really matter too much, because as you can see there's a lot of exposed metal on here too. So if I had this plugged in, I certainly wouldn't be working on this thing with it all in there. Anyway, I'm just going to screw this on here so that I have it in the right position for going to the next stage, and then we'll get the circuit breaker wired in. One of the things you'll notice about the ground fault circuit protector as well is it does have a ground terminal which connects to the outer part of the connections to the rest. Make sure you use it, because that's what's also going to connect round to any exposed metalwork like on the switch and things, to add a ground protection for that too, just in case if there was water on here and you went to flick it, of course you could get a ground circuit forming there as well and it will blow the trip. So that's what you want. So make sure you use the ground connections as they're provided on these switches and fault protectors. When you're putting your wires in too, it always pays to give them a bit of a tug to make sure you got a good firm connection as well. So you screw them down tight, make sure you've got plenty of contact for it. And then the next thing, we're not going to use this end right away. I might later date add an external connection like we were talking about, but for now I'm not going to do that. So what we need to do now is wire these two cables up onto the live and neutral of here, and then we'll be pretty much done. So I'm just going to cut these wires and we'll get them hooked in. Another thing to note too, I don't know if you can actually see it on camera or not, but it's actually written on here white wire and hot wire. Remember what I said, the black wire is the hot wire. You want to make sure you get them the right way around, because when you, or if you extend it out or anything you connect, you need to make sure that the ground wire is the right wire, because certainly in North American wiring, the neutral wire for the mains wiring is also connected to ground. So if you get those mixed up, you potentially can cause problems for somebody further down the wires if they happen to touch the wrong thing accidentally, or if there's a fault and it's supposed to be going to ground and it isn't because you've got your wiring mixed up. So make a point of getting the wiring correct. So white wire to white wire where it says, and your black to the hot side. Don't get them swapped. So one of the last things you want to do just before you screw these screws down for the switch and for the circuit breaker is just make sure that the plate fits over properly, because there is a little bit of twist that these things can do. So just put it over the top, make sure the holes line up, then just lift the plate off again and now just screw them down tight for the last little bit. That way you make sure all the grounds are nice and connected tightly across the devices between the switch and the circuit breaker, sorry, the ground fault interrupter. And we'll be pretty much done. So, with the exception of putting a fuse in, of course, which we haven't done yet. Okay. Okay. And basically, there we have it. Now, nice solid cable, firm connections, plastic all round, nicely insulated, fused. Put a 5 amp fuse in here, why not? Actually, I'm going to put a 10 amp one in because we're going to play around with some big ass power supplies soon. So I'm just going to put a 10 amp fuse in here to get going. Remember, 10 amps in Canada, that's only 100 watts, so that's not a lot. Obviously in the UK, you'd be using the equivalent of perhaps a 5 amp fuse instead for the same device, because twice the volts, half the current. Alright, so that's that. On, off, set and reset. Of course, that's not going to work till there's power connected. And I've already checked my wiring before I closed everything up, which is good. So now we have our box here, and we're ready to plug it in and give it a go. So let's just plug that in over here. And there we go. Of course, nothing is happening right now because my switch is off. Turn the switch on, and I'm able to reset it now. And as you can see, I don't know if you can see that, but they've got the light on here. And if you hit the test to make sure it's working, and there it is, it's reset. So we're on. Sorry, didn't press it far enough in. And hit the reset to test. And it immediately trips out. Turn it back on. And we're good to go. And if I just turn the switch off, of course, it's immediately off. So now we have a handy dandy little bench based fused outlet with a ground fault circuit protector, so that if you or they touch anything you're not supposed to while you're working on your equipment and you introduce a ground fault, then of course it's going to trip the circuit breaker in here. Now you got to remember though, if you touch between live and neutral and not ground, or you've got, you know, both live and neutral and ground together, and you keep this current coming out to the current going in equal, it's still not going to blow. The only reason this is going to blow is if there's a mismatch between live and neutral, because you're leaking away one side to earth via another route out. Now the box I've deliberately chosen for this is all plastic, so that it adds an extra piece of protection as well, because there's no chance of any of this being at any live potential, even if if you've got some bad wiring or anything. So that's all good, and that pretty much completes that. So for anybody who's wondering now, I'll be using this pretty much most of the time to add a little bit of extra protection on the bench. I do have a ground fault circuit protector for the whole house, but you know, I wanted to show you guys because not everybody has one of those, and I don't want people to be working with bad practices in the lab and risk themselves getting electrocuted. So I think that was a worthwhile little exercise to show you how to build one of those. So if you're not sure about how to wire these up yourself, then get somebody that does know how to do it to make one for you. This one is not designed for a lot of power. That's why the mains cable is a little bit lightweight. If you want to do one for a lot more power, obviously you need to use higher duty cables and everything else. So for what I've got right now, this is going to do just fine. And well, that's pretty much it. So I hope you like that, and make one for yourself, because hopefully you'll never have to rely on it, but you know, it's always nice to know that it's there to give you that extra little bit of protection.